In the last video, I sort of drew out what happens in the background with arrays a little bit. Um, but in this video, I'm actually going to write some code. Let's do some stuff with arrays, and don't forget this is the basic style of array. This is not vectors. Uh, but I just want to make sure you have a general sense of what's going on in the background of vectors, because really what's uh, when you have a vector is really just an array, except for has some extra stuff. So everything a typical array has, a vector has, but vectors have some extra stuff to actually be able to dynamically size. So this all really applies to arrays and vectors equally. It's just that once your array fills up, the vector is automatically going to copy it to a new area of memory and give you some more space and wipe out the old one. Okay, so let's just do a new project. Do an empty project. Name doesn't really matter a whole lot. Let me add a new item. I'm going to add a main.cpp. Make sure this is large enough. I don't think we're going to deal with strings, but I'll just include it. It's not going to really hurt anything. I'm going to use the standard namespace. Okay, so our normal boilerplate code. Start without debugging, make sure this all works. Okay, so we're at a good point. Now, let's make our array my array. Int my array, and we'll just make it of size 5. And then we'll give it values. There's a shorthand way of doing this, but I'm going to do it the longhand way, just so you really understand what's going on here. Say my array 0, and we'll just say some random numbers. Okay, so hopefully you understand what's going on here. I've just basically declared an array, and then each element of the array, that's what these are known as, and the array is of integers. I'm giving it a value. So this is some memory address, this is some memory address. Okay, and then within those memory address, I'm giving them a value. So that's all I've done so far here. Now let's add some cout statements. Let's say cout. So now I'm just gonna do a quick memory print. I should say I'm gonna print the value of the variable. So we're gonna say my array 0, and then we'll do an inline. So basically all I'm doing is printing the value. This is just normal stuff we've done, nothing too tricky yet. And then so 14, that's all correct. Let's make this a little bit bigger. Okay. It might be a little too big, but that's fine for what we're doing. Okay, so nothing too tricky there. Let's go ahead and let's do this. Well, let's do one more thing now. So let's go to the next logical step. Is that we're going to print the address. So where this actually sits in memory. So remember the last video I made a memory diagram, and I'd say 100, 102, 103. Well, I wrote that in what's known as decimal, and so typically we see these in hex, and so if you're not really sure what that is, that's just another numbering system. Basically, in our normal numbering system, it's just 0 through 9, but in hex we have 0 through 9 and then A, B, C, D, E, and F. And what happens with that is that's actually instead of 10 numbers within a single placeholder, you get 16. And so 16 is a multiple of 2. And if you remember, we always talk about things as being true and false and binary and 0, 1. And so since it's a multiple of 2, it makes it much easier to deal with things. And And then we actually talk about things being in 64 bits. So 64 bits, if we divide that up for every 4, right? So if we have 16 available, 16, or I'm sorry, 64 divided by 16 is 4, and so each group of 64 bits is actually going to use 4, and that'll I'll show you that in a second. I don't want to get too out there for anybody just yet, but and then we'll say. So really all we're doing is right now we're printing the value and the memory address. Okay, so you can see here 14, and the address is some address. And as I mentioned, remember before, we have 0 through 9, but then we have some letters, and that's what all that is. And we can actually convert back and forth between these. If you want to type into Google hexadecimal or hex, H-E-X, to decimal converter, and you can type this in, and then you can view it typically in binary or decimal or one of the many different numbering systems. But all you really have to understand is that this is a number. So let's do it for all these. Let's go 0, 1, 2, 3, 4. So all we're doing is changing it, so we're doing it for all of them. Let's scroll down a little bit here so we have everything on the screen. Okay, so if you need to pause that and copy that down, go ahead and do that now. So nothing too tricky going on here. We've talked about memory addresses before. We're just printing values. But since we're doing it with an array, we're going to actually see something really interesting when I go ahead and click Start Without Debugging. And I should have made these line up a little bit better. And let's go ahead and do that. Let me make all these 2-digit numbers so that this lines up a little bit nicer. So nothing, I haven't really changed anything. All I'm doing is changing the values just so on our output it looks a little bit nicer. But we could have just as easily run the previous example. Okay. So what you notice is 048C0. So what's going on? Well, this is an array. Remember when I drew our memory diagram and I said these are all one after the other? And so I'd said 101, 102, 103, and then I said that this memory model isn't actually realistic. What happens? So I'm running on a 64-bit computer, and so from the address 0 to 4, what's going on is, so address 0 occupies 8 bits, and then address 1 occupies 8 bits, and then 2 occupies 8 bits, and then 3 occupies 8 bits. And so if you add that together, what is that? That's 64. That's 64 bits. So that's kind of interesting, because what that tells us is our integer is of some certain size, and it's of 64 bits. When we talk about, let's say we haven't really discussed this much, but maybe some of you in COP 2000 talked about the character data type, the char or char data type, and that actually only takes up 8 bits, and so we would see a slightly different output if we were dealing with 8-bit numbers. But because I'm a 64-bit computer, that's what happens, and so. This is kind of cool because we can see these are one after the other, so nothing can exist between 0 and 4 except for my array 0. That's the only thing that occupies that whole memory space. And if you are a little lost, that's okay. I understand this is kind of a little bit of advanced topic, but to really, especially if anybody's a computer science major, you really have to understand the computer's memory, because you can't really kind of just gloss over it and say, oh, I understand some of the programming. And so I wanted to introduce you to that. That way, once you get into your later courses within computer science, you understand that a little bit better. But like I said, this is pretty cool, and there's reasons for this. This computer memory here, when we're dealing with realistic computer memories, sometimes these are randomized, and on Windows, I think this is randomized. So if we were to run this again, we would get a different address, I think. Yeah, so you can see we get a different address this time if I run it again. And that's actually sort of a security thing. with Windows, and you can see it actually didn't even start at 0. This time it started at C. Uh, it's it's um, it's called stack randomization, and it's kind of a really useful feature for security, and it's the reason why we don't have nearly as many viruses as we did for Windows 10 or 15 years ago. But don't worry about that too much. Just get a general sense that when we do things, we're really actually manipulating computer memory, and that's what all this C++ code is doing. And with the arrays specifically, we're saying, all right, these things are going to be one after another. I'm grabbing 5 blocks of memory of 64 bits, which is the size of the array. And before we go, let me do one last thing. So there's kind of a cool operator here, and I'll just go ahead and wipe this because it doesn't really pertain anymore. It's called size of, and maybe some of you have worked with it. Some of you have maybe this is your first time seeing this. But basically, you're saying I'm going to say size of, and then I'm going to say the size of an integer. And this is actually telling you how much computer memory this is going to take up. So let's say size of int, and then let's start without debugging. Well, this says 4, and remember before we said that's going to be 64 bits, right? So because each memory address can hold 8 bits, and then since we're on a 64-bit architecture, and in a standard integer is going to take up 4, and that's actually what's known as the word address size. So this is all kind of cool stuff, right? Because we're actually manipulating our computer's memory. That's really a low-level thing, but we're doing it with code. So let's look at some others. Let's say the size of as I mentioned before, a single character. This should show up as 1, if I remember correctly. It should just be 8 bits. Yep, and we can see it shows up as 1. Let's look at some other ones. Let's look up a long. So this is just another type of integer. It's called a long integer, and this actually on this architecture should also be 4. It should also be 64 bits. And then we have something else called a short, and that one should only be 2. I think that one's only 16 bits. Okay. And then we can actually start to look at more complex types. So I'm not 100% sure that we can do this, but let's we talked about vectors, and we know that vector is a class, and string is actually a class as well. Let's actually look at string instead, because we're so used to using that. So string is actually a class, and ints and all these different numbers are what's known as primitives. And so let's say the size of a string, and let's see if we get a realistic number, or if size of does not work with classes this way. And so we can see this one's really huge. So because this is an object and this is not a primitive number type, we actually get a really big number. So really that was just so you really have a good grasp of arrays and memory and what's going on. But in the next videos, we're going to get more into STL, Standard Template Library, and what happens with our data structures, and actually using and manipulating that. And just maybe in the back of your mind, just keep in mind that when we do these things, we're always manipulating memory. Nothing happens in a computer without manipulating some memory. Maybe watch this video a couple times, really start to understand what's going on, and email me if you have any questions.